of time, whenever we are doing control, people are convinced themselves that they are knowing the control. But what I found, they know how things work, but they do not know why things work. And due to that reason, if we don't know why things work, because most of time you might have seen that we are plotting Bode plot, Nyquist plot, these kind of things we are plotting. We know that how to do plot. Using plot, what kind of information I will get, I also know. But I do not know why that plots are work. Why that will give the stability, these kind of information. So in order to understand that kind of things, we have to go through the some part of the mathematics. And in today's lecture, basically, I limit myself on the analysis which is based on the real numbers. Okay, so I'm not going to cover the complex number, and due to that reason, in this part of talk, most of time, I am trying to explain classical control also using the framework of the real analysis. Okay, and after some time, you are able to understand that calculus is nothing but some kind of algebra, some kind of fancy algebra. That is not a new subject. Okay, because if you see the development before the Leibniz or Newton, several development we have already done without lack of calculus also. So we have to understand that without calculus, how things are actually working fine. Okay, so today lecture is very informative. I am not going to talk any hi-fi thing. Just I am going to talk about the fundamental. So main purpose of today's discussion to introduce the audience to the part of control theory that is motivated by the calculus. And most of time, since I am going to talk about calculus, so some of you might think that that I am going to talk about some kind of mathematical framework, but most of time I am going to avoid that mathematical framework, and I am just going to give you the idea why things work. And we are going to talk about very familiar thing. You might have seen that several times we are using the limit, and based on limit, some problem is there. Hello, are you able to hear me?
Yes, audible. Yes, sir, you are audible.
Okay. So fine. Sorry. So what we found that most of time we are using this kind of things like continuity, differentiability, and definition of continuity and differentiability based on the limit. So one of the most important question that what is meaning of limit? Okay. So and try to understand the meaning of limit. Those who are not familiar with calculus, that is very important. If you are knowing the calculus, after that you somehow you believe on the definition, but actually why definition of limit comes into picture, and how basically that is connected with continuity, and how basically continuity is connected to stability. Okay, because we are doing control system, and one of the very integral part of control system is stability. Whatever control I have designed, and if I am going to plug in that control inside our system, then whatever closed loop system, we have to make sure that it is stable. So in order to understand the definition of stability, I have to understand the connection between limit, continuity, and the stability. So all things are somehow connected. Okay, one of the most important thing is that the modern control system and non-linear control system, particularly we are working on higher dimensional system. Okay, and it is possible to show that comparison of quantity in higher dimensional system or higher dimensional space is not so easy. So how to do compare in higher dimensional space? That is another very important things to understand. And for that, I am going to use one kind of mathematical framework that is called non-linear. So do not worry about these kind of terminology. I will tell you just a story. Okay, and finally I will end up to the control design. And why this kind of approach is very important, because nowadays we are moving towards much complex systems, like we are talking about some kind of robotics that is controlled from your room, we are going to talk about the network control system. We are going to talk about biological system. We are going to talk about some kind of robotic doctors. We are going to talk about chemical computers. So somehow now we are exploring some kind of new classes of system. So you have to understand that how one can develop new theory for that class of system. What kind of primitive background is required to understand new classes of system. We have already understood lot of classes of system, but still that is very fraction of the total system. Most of time when system is very complex, then I cannot talk about quantitative analysis. Quantitative analysis means exactly I know that what kind of things is going to happen in terms of numbers. But qualitative analysis will give us the brief idea, very brief idea. And most of time we are not going to talk about exactness of the solution or approach. We are just trying to understand that what kind of approximation, and using approximation how much things I can generalize. And each kind of approach is equally applicable for game theory, computer science and information theory, machine learning, these kind of things. So I hope that after means today's lecture, you are able to understand, or you are able to find some kind of connection of this theory with these classes of system. So let us start the today's lecture. So first part of lecture, I am going to tell you that what is connection of science and engineering. Okay, and why I have to tell this story, because nowadays if you read books, you might have seen that social science people are also writing science. Environmental people are also writing science. Okay, so basically how their science is different from our core science. So for us, science is just four: physics, chemistry, biochemistry, and biophysics. Okay, and why we are telling these four as a science? Because they are laws and reduction. Okay, why basically we are making laws? Because we have some kind of system, and after that we are trying to see that if something is varying, some parameter is varying, then what is response of the system. And due to that reason we are basically develop several law in physics, chemistry, biochemistry or biophysics. Okay, just take simple examples of the Ohm's law. So I have some kind of linear resistor, and I know that if I apply voltage, then how much current is going to flow through that resistor. Okay, so somehow I want to do some kind of prediction. So basically what we hope that in this core science, if I will do some kind of experiment, and that experiment is valid for wide range of parameter variation. It means that if I perform some kind of experiment in India, same kind of outcome. I hope that if I am going to perform same kind of experiment in same situation in US or some other part of the world. So that is the meaning of hard experimental science, and main theme is that to explore the nature and make new discoveries. So for me, environmental is not a science, a social is not a science for me, for our definition or whatever definition or we are going to give. Now, what is our aim and our goal? Most of us are engineers. So what basically we are doing, we are taking the information of experimental science, that is hard science, and after that we are trying to create some kind of new devices and system, and our main aim to serve the humanity. Okay, so we are going to develop some kind of device which is applicable for the humanity. And what basically we are going to do, our tools is basically heavily dependent on the science. So we are taking information or laws from the science, and after that making interconnection of several laws, and after that we are going to give some new systems to the humanity. And after that, what is main framework? Since whatever system I am going to develop, so we have to teach same kind of philosophy to other people in the other part of world, and for that some language is required. And if you see the language of control system or system theory, then that is mathematics. Okay, so just for 1 minute, check her.
Yes, sir.
A lot of noises are coming. Could you please stop the noise? You can see that someone is talking.
Mr. Deepak, can you please mute yourself? Mr. Deepak? Mr. Deepak, can you please mute yourself?
Organizer, could you please mute them?
Okay, sir. Okay, sir. Sure, sir.
Okay, because whenever noise is coming, it is very disturbing.
Yes,
Okay.
sir. Yes.
Okay. Okay. So thank you. Thank you. Okay. So here, what is our main theme? You can see that we are going to believe on science, and after that we are going to do some kind of intersection of science, and after that mathematics, to develop some kind of new system. Okay, so due to that reason we have to learn mathematics, because I want to represent some kind of system, I want to represent some kind of law, I want to implement something. Due to that reason, mathematics is very important for us.
All participants are requested to mute their mic, please. All participants are requested to mute their mic.
So whenever we are going to develop some kind of new theory, what is most important, that I have to develop some kind of system. Still I haven't defined what is meaning of system, just wait for that. So what happens, suppose that I have some kind of physical system. Okay, physical system, you can take anything. If you are electrical engineering, if you are belongs to electrical engineering discipline, then you can take resistor, inductor, capacitor as a system. If someone from the mechanical engineering, so they can take system as a mass, spring, dampers. If someone from chemical engineering, then they can take system as a some kind of chemical reaction. Similarly for biological people. So I have system, and it is possible to show that I can represent or mimic that system using some kind of mathematics. Okay, so and what is beauty, that I will give some input to the system, and I am going to give same kind of input to that mathematical model or some kind of mathematical differential equation, difference equation, and whatever things. So I am going to get same kind of response. Okay, so what happens in physical system, I do not know what is going inside the physical system, but at least I know that I am going to capture that system using some kind of black box things. And if I am going to give same input to physical system and black box things, then output remains the same. So I have input and output. So how to actually define map between input to output? So it is possible to show that if just input and output is given to me, then in infinite many way I can actually correlate between input and output. And due to that reason, for one system I have infinite many models. That is the beauty. Okay, so now if you are working with control system, then try to select some kind of model which is simplified, because whenever you have some kind of robust control, then if some mismatch between physical system and abstract system, means those kind of mathematical model which we are thinking that in this way that particular system is going to behave. And now what you can do, you can apply some kind of robust control technique. So you can take very simple system, then still you are able to mimic the reality. Suppose you have to do some kind of analysis. So for analysis purpose, most of time we are selecting complicated models, because I want to capture the phenomena. So depending on your discipline or your test, or based on your research area, you have to select different type of model for the same system. And which one is the good model? So these things are telling. Since I have input and output data, so I know that what is output, I am going to measure the output, and after that I have represent same system with some kind of mathematical representation. I will I will pass again same input information with this mathematical representation. I am do analysis, and after that I will do some kind of computer simulation or some kind of analog simulation, and I am going to match that whatever output coming from here and output coming from this mathematical model too. If that is agree, then we are telling that this physical system is actually represented by this abstract model or some kind of abstract mathematics. Okay, so what is main important point here, that I have one system and I have infinite many models. Okay, and due to that reason you might have seen that in pendulum system I have thousands of papers, and it might possible that all 100 paper we are going to take different mathematical models. Okay, so that is very important thing. So one area of research, that even if model of some system is existing, you try to develop some kind of new mathematical framework such that you come up with some more valid or most of time we are actually whenever we are working in control system, then we try to select simple model. So you can tell that okay, this system is very complicated, but I can represent that system with very easier model or very simple model like first order, second order, like that. So if you come up with that, then also that is one of the very good contribution, and people are doing that. So now let us come to the system. So because several times I am talking about system, but what way basically we are talking in control system, we are following the mathematics heavily. And after that, whenever we are come up with some new terminology, we try to define that terminology. Okay, so one of the most important terminology in control system or system engineering is system. And what is meaning of system? So we are simply telling that if you have some kind of physical object, you try to do measurement, and if you will do some kind of measurement, it means that if you are going to do some kind of experiment, you are going to get some kind of unique number. Suppose that this is robot and they are going to measure the height of this object, then you can see that this robot using some kind of measuring device, they will get some kind of unique number. Then we can tell that whatever system in front of this robot, that is whatever object that is in front of this robot, that is called a system. So unique number is very important. Okay, so you have to do measurements. Meaning of measurement means that I am going to apply some kind of input. Okay, you can see that in order to measure the height, I am going to use two rays, and based on some kind of geometry, I am going to measure the height. So every time whenever I am talking about measurement, it means that I am going to apply some kind of input, and after that I am going to look towards the number. So believe on me, number is just not a number. That can tell us various things if you listen to that pattern or that number. You might have seen that whenever we are going to the physician, whenever we become ill, at that time they are just asking some number to us. They are telling that what is your blood pressure. If you don't know, they will measure. They are measuring your temperature. They are measuring your pulse rate. And after that, they are telling that you have this kind of disease. So you can see that in order to guess the disease, they are just seeing some kind of pattern whenever they are prescribing some kind of test. Also at that time, we are just giving some, we are getting some kind of graph, and inside graph, we are just estimating the number. So if you listen to the number, then you are able to understand a lot of things. So whole control theory is the game of numbers. Just we try to understand the number. So what is meaning of number? So basically, whenever we try to interpret the number, then we are giving some new terminology that is called model. So figuring out how numbers are changing as you observe with this system. So suppose if I have some kind of resistor, what I am going to do, I will apply some voltage, I will measure some kind of current. I will apply different voltage, again measure some kind of current. After plotting, you can see that I will get the intrinsic property of that particular object. Since I have resistor, so using any set of input and output, suppose resistor is linear, then I will tell that what is value of resistance. So just based on measurement, I can able to characterize the uniqueness of system. We all are already well aware that if I have one system and one resistor, then they have unique value. Okay, so now you can apply any current and any voltage. I am assuming. What kind of assumption? Assumption is that that resistor is real. So just by measurement, I can able to figure out the unique number, and that represent the resistance. Similar story for capacitance, inductance, mass, spring damper, and any experiment, any physical experiment whenever we are going to do. So just we try to play with numbers, and if it is whole family of system, then model may be promoted to being called a theory. And if you see the Newton's law, you can see that Newton's law is applicable for very large class of system. So I will promote that kind of model to some kind of theory. So in this way, basically we are developing models theory whenever we are dealing with the physical science, okay, or experimental science. But how basically we are developing model using mathematics? So that is called axiomatic way. Okay, so in science we are able to perform experiment. In mathematics we are not doing any experiment. What basically we are doing, we obviously motivated from the hard science, and after that what basically we are doing, we are defining a set and we are assuming some rule about their structure, and these rule are called the axioms. Okay, so axioms, now you might have seen that what is meaning of axioms, that axioms is nothing but some kind of assumptions only. And what happens that people of the whole over the world that is going to believe that assumption, and why they are believing, because they are assuming that that is sensible. Okay, so similar kind of a story. Suppose that I have resistor, then we are going to believe that resistor, whenever some kind of current is going to flow through some kind of resistor, then I am going to get some kind of voltage, and relationship between voltage and current V equal to I and R in some limited region. So that so here you can see that every time I am assuming that whatever amount of charge that is quantized, and we are assuming 1.6 10 power minus 19 something is there, some number. So we are believing on that number, and after belief we are also doing experiment to check it. So obviously that is another step. So most of time we are believing on that kind of assumption without without assuming that some kind of mathematical proof behind that. Okay, so if that kind of assumption we have, that is called axioms. Okay, so in mathematics we are taking this set, and after that we are forming some kind of rule, and using that rule we are going to develop some kind of interesting theory. But in science we are going to do experiment, and then we are going to develop some kind of new theory. So in today's lecture I am going to connect these two, science and mathematics, and after that I will tell you that how to select set, how to select rule, what is meaning of assumption, what is meaning of axioms, what kind of rule we are going to follow. Okay, so up to here, if you have any question, a specific question, then please let me know. Anyone? Are you able to hear me?
Yes, sir. Your voice is coming, sir.
Okay.
Yes, sir.
Okay.
Yes.
So
yes.
If you don't have any question, then I am going to now start the story. You can see that first part of mathematics, what basically we are doing, we are telling that I am going to select something. Okay, and I have defined set. So what is meaning of set? We have already familiar with set. So any unordered collection of objects. So what happens that I have to do some kind of study. Suppose that I have to study some kind of physical system. So let us try to see that how basically we can select this set. But suppose I have to do a study of resistor, then what kind of things is required for us? So I need some kind of measuring instrument which is responsible for measuring the voltage. I am going to take some kind of measuring instrument that is going to measure the current. Okay, so I have voltmeter, I have ammeter, and after that I have some kind of graph paper, and obviously I have some kind of element. So these all four elements I will collect together. So that is nothing but one set. Okay, so set is any unordered collection. So either first you can select ammeter, then voltmeter, then system, and then other things. That doesn't matter. Order doesn't matter. But we know that this world is very, very systematic. Okay, systematic means if there do not exist some kind of symmetry, then it is very difficult to learn or to develop some kind of things. And due to that reason, I have to move from unordered world to ordered world. And due to that reason, you might have seen that, and during school time we have also seen that once we familiar with set, then another notion, that is notion of Cartesian product come into picture. And what is meaning of Cartesian product? They are telling that now you can take two set. Okay, and suppose I have set A and set B. So set A contains some kind of triangle and set B contains some kind of a star. So it means that you can take any element inside A and B, and meaning of this A Cartesian product B, that we are going to develop some kind of relation between this element to this element. And you all are already familiar that if I have 3 elements and here I have 5 elements, then I have these many maximum possible relationship exist. Okay, if you see, and this relation is very, very ordered. Okay, suppose that if you have 1 here and 2 here, and if I am writing 1 2 and 2 1, and if I am going to represent 1 2 and 2 1 in 2-dimensional plane, you might have seen that both are different. Okay, so order is very, very important. If you reverse the order, then quantity is going to change. Okay, so what happens? First, I have taken unordered world, develop unordered world, and after that I am going to move towards ordered world. And in that ordered world, I have one very, very unique element that is called function. Okay, so and what is meaning of relation? That relation is that if you take any here, you can see that any combination you can take, that is called relation. Okay, but whenever I am going to talk about function, then what I am telling that if you give some kind of input, then whatever output that is going to come into picture, that is unique. And I have, whenever I have defined the system, you might have seen that what kind of definition I have given, that I have some kind of machine or some kind of system. I am going to make some kind of measurement, and after that I am going to get some kind of unique number. So what is a story? A story is that whenever we are going to develop some kind of machine, that is nothing but some kind of function. Okay, and some kind of in higher dimensional we are telling same thing as a map. Okay, so whenever we are talking about function or map, at that time we are going to make sure that whatever input we are going to give or whatever output that going to comes into picture, that is unique. Okay, and due to that reason, now whenever I am going to develop some kind of system, at that time I am going to assume that whatever machine I am going to develop, that will satisfy the property of function, not the relation. Okay, so it means that one object, one output might associated with 2 different input, but if you will give one input, then output is always unique. From this graph, it is clear. You can see that here, this is not a function. Why this is not a function? 5 is associated with A and C also. But here you can see that this is a function. It might possible 1 and 8 both are associated with B, but for one entry, one input, there do not exist this kind of relation. Okay, so function, whenever we are talking about function, we are going to talk about uniqueness. So how basically we are now going to develop the theory? First I will define the set. So set I will take physical system, input, output. After that I will define the relation between input and output. So I will take the help of Cartesian product, and after that I am going to take only those kind of relationship which represent the function. Okay, so all element, all differential equation, difference equation, stochastic differential equation, time delay equation, we are going to use in control system or system engineering, that will follow the definition of function or mapping. Mapping most of time we are going to use for the higher dimensional space. Now I know the 3 basic element. Okay, after that, using 3 basic element means I know set, Cartesian product and function. Is it possible to define some kind of operation? Because you might have seen that during our childhood time we have a small calculator, and using that calculator I am able to do lot of operation. And if I will increase the hardware requirement, then what happens? That things become little more difficult. So what basically we our idea in hardware level, I want to only do very small operation, and after that what I will do, if some complicated operation comes into picture, I will actually convert that complicated the operation into some primitive operation, and after that I will work with that complicated expression. And you might have seen that whole computer system is based on 0 and 1. Okay, so we try to understand that why only a small hardware is able to do so many work. What is basic philosophy? And basic philosophy is basically based here, that is called binary operation. Okay, so what is meaning of binary operation? You can see that whenever we are talking about binary operation, we are telling that, okay, suppose I have some kind of set, and now I will do some kind of operation or define some kind of Cartesian product, then again I map to same set. So it means that since I have started with 0 and 1, so you can see that whenever I am going to add 0 plus 0, I have taken 0, 0 plus 1, I have taken 1, 1 plus 0, I have taken 1, and 1 plus 1 I am not defining 2, because if I will define 2, then that is not going to lie between 0 and 1, because I have selected 0 and 1 only. Okay, so I have only two possibility. Either I can select 0 and 1. So why basically we are selecting 1 plus 1 equal to 0? That is actually that kind of idea is given by next operation, that is called group. So group is going to tell us why 1 plus 1 only equal to 0, why 1 plus 1 not equal to 1. Okay, because I have two choices, 0 and 1. So this operation, that is called group operation, they are going to give us guarantee that 1 plus 1 equal to 1 plus 1. If you will take 0, then everything remains defined. Okay, and for that they are based on these three axioms. And what that kind of axioms, that is called associativity, identity, or inverse. And I hope that you all are already well aware about. If you don't well aware about that, then what you can do, you can take any book, any fundamental book, and try to see, because during school time we have already seen what is meaning of associativity, a plus b plus c, and now you can take a plus b or do operation, and after that you can add c, and similarly you can take a ought and b plus c, and after that you can apply operation, that is called associativity. And please be careful, associativity is not always satisfy. There exist several counterexample on that where associative application is not satisfied. For simple number it is obvious. Similarly, identity inverse. So what happens, what is main crux of the matter, that I have unordered world, and I have developed some kind of operation inside that unordered world. I will get another ordered world, and that is called magma. If magma will satisfy these kind of condition, then I will get some kind of another mathematical object, that is called group. And it is possible to show that whenever there exists symmetry, there exists invariance, always there exists some kind of mathematical notion, that is called group. So mathematics, whatever mathematics that is developed by the mathematician, they are very much well aware about the physical phenomena. Somehow in abstract level they are knowing that what kind of primitive of information is required to capture something. So whenever I have some kind of invariance, symmetry, at that time it is possible to show that is nothing but some kind of group come into picture. And if that object is symmetric with respect to two binary operation, then that is called ring. Ring means I have more level of symmetry. So I have started with scalars, and I have deal with set, magma, group, ring, and field.
All are requested to please. Sir, Shyam Kamal sir. We have muted all the participants, so you are also muted. So please unmute yourself, sir.
Okay.
Yes, sir. It's okay now.
Okay, so these are the algebraic structure, and believe on me that all theory, whatever theory we are learning, or whatever computer system, whatever complicated system we have developed, that is just based on these particular structure. They are not going beyond this structure. Okay, just you have to understand how basically whenever we are going to develop some kind of new operation, then how basically that fall inside this particular structure. And why I am telling this kind of structure is very, very important. Suppose nowadays you might have seen that people are talking about chemical computers. Okay, so in chemical computer, using chemical computer, what we are going to do, again, suppose I have to do some kind of operation, like I have to add 1 plus 1. So we have to understand that how basically 1 plus 1, if I will write using keyboard, then chemical computer will do two kind of chemical reaction, and they will generate 1 plus 1 equal to 2. So it means that I have to select some kind of minimal number of chemical reaction such that I can represent all kind of operation. Okay, so if you do not understand this kind of structure, you are never able to build some kind of new computer which is based on chemical reaction, and it might possibly in future some more thing come into picture. I don't know. Okay, but what we know that almost all operation we are basically doing using these kind of structure only. And these things, set, magma, group, ring, field, I am not telling the what is definition, just I am telling that whenever we have symmetry, then there exists group, ring and field. For a scalar, whenever we are moving in higher dimensional space, at that time vector space comes into picture. In vector space, I do not have some kind of notion where I can compare things, and due to that reason some new notion inner product come into picture. And suppose that I have some kind of vector space, and again I will, after doing some kind of operation, we will in on vector space, that is called algebra. Okay, so here these actually land up to two different subjects. One subject is called abstract algebra, another subject is called linear algebra. So if you see the linear algebra, at that time we are just talking about the most of time field and vector space. Using these two things, I have developed an inner product, obviously. So in these three, using these three things, we have developed the linear algebra. And whenever you are reading abstract algebra, then these kind of things are developed. Whatever cryptography, whatever things we are developing nowadays, all are basically based on this. So what is my suggestion? If you want to learn, or if you want to really know why things work, then please go through this linear algebra and abstract algebra. Okay, and there are various mathematical books are available in this direction. Okay, so let us try to see that what is importance of the linear algebra for us. So linear algebra, obviously starting with some kind of set, and inside set we have just two operation, that is addition or a scalar multiplication. Okay, and inside set it is possible to show that for control engineers I have just three different classes of element. One class of element we are telling that I have numbers, another class of element we are telling I have functions and I have to operate on functions. Third class we are telling that I have some kind of element that is called matrices. Okay, so I have either element in form of column vectors, in form of matrices, or in form of the functions. Okay, and if you are able to understand these three things, then you are able to learn the primitive of control system. So in control system I have just three elements. Column vector, I hope that you all are already well aware what is meaning of column vector, where each entry is some kind of numbers. Functions, it might possible that can be represented in form of column vector, but each entry is actually changing with respect to time or some other parameters. And after that, matrices means now I have not just column, I have row also. Okay, and each entry might be function of time, might not be function of time. And using these three things, I have three different spaces. So column space, function space, or matrix space. So in whole control theory, we are just using these three spaces, and in today's lecture we are going to understand. In all three spaces, it is possible to show that just we understood the simple operation. Then I can add two functions also, I can add two columns also. Column means if element in form of column vector, I can add it, and we can also able to understand that how to add or multiply two kind of matrices. Okay, but primitive operation is just remains 1 plus 1 equal to 0, 0 plus 1, that kind of things. So if you understood this structure, it means that you know that on hardware level what kind of operation I have to develop and how to map. Suppose if now if you have, you know how to add two numbers. Okay, so after adding two numbers, now suppose that if you have to add two column vector, how basically we are adding? I am telling software program you can take element wise and after that you can do addition. Then what happens again, that transfer to the simple addition. Suppose if you have to add two functions, now I am not going to develop some kind of new hardware to add two functions. What I am going to do, at one time instant I am going to see two functions, again I have two different numbers and I am going to add two numbers. Okay, so in software level I am going to interpret function at some time as a two numbers, and I will give that kind of instruction to hardware to add just two numbers. In this way, theory, a small hardware can be able to add two column vector, two functions, two matrices, or any two polynomial, anything you are able to think like this. Okay, and so due to that reason, if you see in vector space, I have just two operations, and I have some kind of exams, 10 exams I have, such that, so I'm not going to discuss exams in today's lecture. So you have to just understand that why we have to learn vector space. Vector space just give us the way that I have functions, then how to add two functions, how to multiply two functions, and what is multiplication of some function by some number, and how to map that operation to simple operation. And if you are in vector space, then you are able to understand what is meaning of linear independence, basis, span, etc. Using one example, I will tell you a story. And after that, in vector space, I do not have any notion of the where we can talk about the comparison. So comparison means, suppose I have some element in higher dimensional space, how to compare it. So for that I need this operation that is called inner product. Okay, so membership set started with membership, and after that I have independent vector. Independent vector means no extra vector. So you are in two-dimensional space. It is possible to show that using two independent vector 1, 0 and 0, 1, and you can scale it out and you are able to move anywhere inside the space. So two-dimensional space just need two independent vectors to span the whole space. Similarly, if you are in three-dimensional space, you just need three vectors 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is one set. It might possibly, apart from this, I have different set also. But what is main thing that using three vectors only you are able to move the whole space. And if you see, if it is possible to move whole space using three vectors, it is possible to show all are linearly independent. Okay, so again, if you gone through the linear algebra, I have definition of that. And after that, what is meaning of basis? No many, no few. So exactly three vectors are required to travel in three-dimensional space, and vectors are required to travel in n-dimensional space. And what is dimension? The number of vectors in basis. So why we are telling this is two dimension? Because you can see that using 1, 0 and 0, 1, I can able to travel in whole space. And due to that reason, we are telling that as a two-dimensional space. And if you understood these kind of things, one very, very important, that vector space, they are telling that using two operation only, you can able to add any two numbers, any two functions, any two matrices, any two polynomial, any two chemical equations also. So or quantum, if you come to the quantum level, it is possible to show that using two operation you can also work for the quantum level. And inner product, I have already told you that is making vector space rich using the help of this notion, and that will talk about orthogonality, length and angle. And you might have seen that orthogonality, length and angle we are using at several places. Let us see the very, very simple example. So I have taken the example of the functional space. Why I am taking example of function space? Because you have seen that whenever I am giving some input to the system, then I am getting some kind of output. Okay, so system is behaving like some kind of function only, I have told you. And if my input is time varying, then output is also time varying. that kind of things. So basically system is mapping from some interval to some space. Okay, why I am telling that, suppose I have some kind of machine app and AB, this is called closed interval. Suppose that I am just talking in this time interval. So you can see that here that maps, and if I have n dimensional system, so I have r power n, means suppose x dot equal to fx, if I will tell, so I have n number of independent vector is required to understand that space. So this kind of mapping is there. Okay, now question is that if I have two functions, then how to add two functions? And suppose at hardware level, I just know how to add two numbers. So I have already told you that what software program is doing, they are interpreting function at each time interval t and t, and they are just adding two numbers. Okay, and I have to make sure that this will consistent with all axioms of vector space. 10 axioms we have, and it is possible to show that if you add the two function pointwise, then they will satisfy all property. And due to that reason, whenever you have to add two functions, at that time in software level, I am going to write this kind of program. After that, if you have to multiply some kind of function or scale out some kind of function, then basically what happens, whenever I am applying some kind of signal to the some system, what basically system is doing, they are scaling out that signal. So how to define a scaling up and down? So using some kind of scalar multiplication, and again that is pointwise application. And since I am in Rn dimensional space, it is possible to show. So for time being, please do not worry. So that is called norm, and I will tell you how to define the norm. Norm is nothing but some kind of distance, some generalization of distance. And again, you can see that I will tell you that if you know the notion of absolute value, so if on your hardware level, if you are able to calculate the absolute value, then you are able to calculate norm of any vectors, any matrices, any function. So that is the beauty. So mathematics is telling that how much minimum hardware is required to do any kind of operation. And due to that reason, if you learn the mathematics, then you are able to understand that for new system, how many minimum number of hardware is required. So that is very, very important. Now let us try to see that Fourier series. Most of time during our college day, we are learning about Fourier series, and what our professors are telling that just you can remember it. But using this kind of notion, you can see that there is no need to remember. What basically Fourier series is telling, that suppose if I have some kind of periodic function, suppose periodic function like sine, cosine, something you can take. So they are telling that function can be represented using some kind of different coordinate frame. So I have represented function f using fx using some kind of coordinate frame where I do not know what is behavior of that function. What I am going to tell now, you can able to capture the behavior of any periodic function, and obviously piecewise continuous. So do not go on that. Just you can concentrate yourself on periodic function, and after that it is possible to show that how to extend it for other classes of system. But for time being, you try to understand the phenomena. Phenomena is that I have to represent this function fx, and due to that reason, fx is lying in some space, and in order to represent some vector in a space, I need some kind of independent vector, because I have told you that if I am in two-dimensional space, so I need 1, 0 and 0, 1. Similarly, it is possible to show that if I select cos kx and sin kx, and you can vary k from 0 to infinity. Okay, so I have combination like cos x, sin x, cos 2x, sin 2x, cos 3x, and sin 3x. And if you see all cos kx and sin kx, they are linearly independent. And how to check? You can multiply with alpha and beta and equal to 0. Then it is possible to show solution is only alpha equal to 0 and beta equal to 0. And I have to expand the function space where any periodic function is going to lie. And basis is here. You can see that k equal to 0 to infinity. It means that infinite number of vectors are required to represent some kind of function. So whenever I have some kind of function, it means that I have infinite dimensional space. Suppose fx is 2 pi periodic. You might have seen this kind of formula. Let us try to understand this formula using the idea of vector space and inner product. Okay, so what basically I am telling, that function fx can be represented using these two coordinate frames, cos kx and sin kx, and cos kx and sin kx is infinity. I do not bother about that. So what we have to do, whenever I am telling that I have some point 1 and 2 in two-dimensional space, so what we are telling that if I project that 1, 2 point in x-axis, then length is 1, and y-axis, then length is 2. So here also, if I am going to represent fx in this coordinate frame, then I have to do projection. Okay, and how to do that projection? So inner product is telling that how to project something in some other coordinate frame. So you can see that I have coordinate frame equal to cos kx, and I am going to project function fx. And if you define, and here please do not worry how to define inner product, just for time being you can forget about that. So what I am going to do, using this kind of operator, I am going to project fx on cos kx, and after that I have to see the unit vector in that particular direction. So I have to see the unit vector in that direction cos kx, and due to that reason I have defined the cos kx and dot product with cos kx means inner product with cos kx, and obviously it is possible to show that is cos kx square, and finally it is possible to show that is nothing but pi. Okay, if k not equal to 0, and if k equal to 0, then obviously I have 1 by 2 pi that comes. So forget about that story. So actually what basically we are telling, now I have different coordinate frame, so I am going to again project that function, and you can see that ak and cos kx. So ak is coordinate, bk is coordinate, and how to define coordinate? By inner product, and I have to project vector in cos kx direction and sin direction. So similarly, if I have 1 and 2, so what we are telling that in x-axis direction, what I have to do, I have to see that what is component in x direction. So for that also we are using same kind of logic. So using this kind of logic, you are able to understand the Fourier series. Okay. Similarly, you are also able to understand this Taylor series. So Taylor series, now basis is 1 x, x square, x cube, x power 4, like that. And again, if you do same kind of inner product, then you are able to develop some kind of Taylor series also. So if you understand the framework of the vector space and framework of the independent vector spanning basis, dimension and inner product, then you are able to understand that if you have some complicated signal, then how to represent that complicated signal into some simple signal or some kind of signal which you have already know. That is the idea. So I have complicated coordinate frame, and vector space or inner product space gives us the idea how to represent class of complicated signal into some simple signal. Okay, so fx is any periodic signal, then I can represent like this. Or here 2 pi, you can now take period equal to L. So similarly, these things remains the same. Okay, some modification, a small modification is required. So what you can do, you can go to your home, try to see same kind of framework for Fourier series, discrete Fourier series, and everything you try to see in this framework. Now, I try to talk. So till now, I was talking about the algebra. Okay, and when I have started this lecture, you might have seen that I am talking about calculus to control. So why calculus is important for us, we are trying to see. So first question is, calculus is the new subject. Let us try to understand the calculus. What basically calculus is telling, suppose that if I have some kind of slope, if slope is like this, so using algebra or trigonometry or some kind of geometry, I can tell that what is slope of this. You all are already well aware that what is slope, what is tan theta, we are calculating during your school time. But what happens during college time or higher school time, suddenly calculus comes into picture. And what is main motivation? They are telling that if this is consistently changing, then how much force if I will give such that it will move from here to here. Here you can see that if you know what kind of force I will apply here at initial point, same kind of force if you apply, then you are able to move from here to here. But if this is changing, then you cannot tell that using same force I can move from here to here. And due to that reason, Newton's or Leibniz has developed this kind of theory that is called calculus. So calculus is nothing but just advanced algebra with some kind of geometry. And why calculus is so much so much important because it is able to solve very, very complicated problem. You can see that this problem is not simple. Slope is changing everywhere. Okay, so now question is that how to convert this complicated problem into just a simple problem. And for that, what basically we are going to do, we are telling that, okay, whenever you have complicated problem, you try to zoom it. And if you do infinite zoom, then you are again getting this kind of a structure. And you know, if you have this kind of a structure, then how to calculate the slope. So you know this. So from algebra and geometry, you know, but you do not know this. So what you can do, you can zoom it. So now question is that how to zoom it? What kind of macroscope, mathematical macroscope is required to zoom it? And it is possible to show that that mathematical macroscope is nothing but the limit. So limit is nothing but some kind of macroscope which is telling that how to zoom some kind of curve which is continuously changing. Okay, so even if you do not know what is meaning of limit, but if you know that I have some kind of complicated or continuously varying curve, and now I have to zoom infinitely many zooms such that I can come from here to here. And how to do? Mathematically we are telling that is limit, but physically we are just stretching it. Okay, so zooming is on the curve, and after that basically if you do zoom, then basically I am getting this kind of shape, and once you will get this kind of shape, then I can tell that now I can going to apply some kind of algebra and geometry. Okay, so basically by zooming we are going to apply the algebra and geometry. Okay, and if you see the integration, so integration is again based on the same principle. What basically we are going to do, if I have this kind of area, I know what is area behind under this particular curve, but if this is changing, so I do not know how to calculate it. So again they are telling that you come here and you try to zoom it, and if you do infinitely zoom, you can see here I have two structure. One structure is rectangle, another is triangle, and I know from the algebra how to calculate area of triangle and rectangle. So just you have to add it. Okay, so everywhere what we found that in calculus one important thing is required, that is called macroscope. So limit is nothing but one kind of macroscope, and using that macroscope I can able to extend anything. Okay, and if I extend, then I can able to apply algebra and geometry to do all kind of operation. Okay, so macroscopic level, if you see, then everything is just a straight line, and due to that reason only I can able to apply the linear algebra there or algebra there. Okay, so due to that reason, if you see the fundamental definition of the derivative or area under the curve means integral, always limit are involved. So limit is just telling us that how to zoom something such that complicated operation is reduced back to simple operation. Okay, and here you can see that limit, if you see the limit here, so limit inside the definition of limit, basically what happens that again something is involved, and that thing is like this. So suppose I have this kind of function. So intuitive meaning of limit, if you do not go to the definition, just they are telling that at this point what is height of this function. So due to that reason I can able to tell that okay, limit, if I will do infinite zoom here, then and x is 3 minus, at that time px is 6. Okay, so they are just talking about height. So you can just plot a function if you have one dimensional function. I will tell you the story how to extend for higher dimensional function for the same thing. So but now try to understand, if this definition is very, very important to understand the limit or to understand the control system or stability also. So what we found from the previous discussion, that if I have some function that is changing with respect to time, so I have to apply some kind of macroscope, and I have to apply macroscope for such a way such that something is converted into a straight line. Okay, so x tending towards a, fx equal to L, it means that I am going to apply some kind of macroscope to fx on function. So I am going to zoom the function fx, not the x. Please be careful. X is some kind of element, input element, and fx is some kind of output quantity. But I am going to apply some kind of macroscope to the output. And due to that reason, you can see that you can take some function, and suppose if you know that I am going to talk about limit at this point, so you can zoom it, okay, and try to see that whatever after zoom, if you are at this point A, then whatever these 2 points after zooming, whatever these 2 points comes into picture, that is related to epsilon. If you are able to establish this kind of relation, then I am telling that there exists a limit. Okay, so now whatever zooming process, that is mathematically represented like this. So you can see here, be careful, they are telling for every epsilon, and try to see that what is meaning of epsilon here. Epsilon is telling that what is distance of this function fx, you can take any point with this value L. So they are going to concentrate each and every point inside L plus epsilon and L minus epsilon. So same kind of things. So distance of this point from this point to this point. So first I have to select epsilon greater than 0, and this symbol is called for all. Okay, so if I take anything, any quantity between these two, so it is possible to define delta. There exists. This symbol is called there exists. Okay, so this is coming from mathematical logic. So for every epsilon means I have some kind of, this is also called ball. So output ball, if you are in output ball and corresponding to output ball, if there exists some kind of input ball which is defined like this, then we are telling that this is nothing but some kind of macroscope. And using that macroscope, now you can able to define continuity and differentiability, both, if function is differentiable. Okay, so I hope that you are able to understand the idea. So whenever I am telling something as a limit, it means that function is somehow bounded nearby of this. So that kind of information we are also telling. Okay, so if one-sided limit is exist, then I am just able to talk about boundedness from one side. Okay, now let us try to see the continuity. So basically limit and continuity, that actually go hand by hand, hand in hand. But only exception is that if some hole is there, then I can able to talk about limit. Limit is nothing but distance from here in one-dimensional curve. But I am not able to talk about the continuity if some hole is there. So with hole exception, both things are exactly equal. And due to that reason, if you check the literature, same kind of definition people are also using for the continuity. So they are telling that some function fx is continuous at some point x if this kind of relation will satisfy. So since limit, we are not distinguishing between limit and continuity if I have not a hole. Okay, if hole is there, again some new definition is required. Okay, so at hole limit exists, continuity doesn't exist. Okay, but it is possible to show that whenever we are talking about world, and if I want to do the prediction, so prediction will work. Why prediction will work? Because something is continuous. Again, if you see the definition of limit, you can see that again differentiation. So fundamental differentiation is actually based on the limit. And what limit is telling? If you have some function fx, so okay guy, what you can do now, you can zoom it near the f plus h. So that is zooming process. So this is just telling zooming process. After zooming process, I have some kind of a straight curve. So now you can apply the algebra. So things become very, very simple. So what kind of message I am going to transmit here? That calculus is just a fancy subject where limit is working as a macroscope, and how basically I can learn or understand the limit using the help of algebra. Here you can see that everything is algebra. Nowhere, nothing apart from algebra is involved. So based on algebra, I can able to define the limit. Okay, I'm going to define the limit of some function, one-dimensional function. When you are in higher dimensional space, then this absolute value is just converted into norm. Okay, because norm is just giving the way how to define distance in higher dimensional space. And I have told you that if there is no hole, then definition of limit and continuity exactly same. So, and limit and continuity both are talking about the local boundedness of something. So now you are able to understand that how basically one can define stability, that if I have system, so we expect that if I will give bounded input, even if that is a nonlinear system, if I will get some kind of bounded input, in some sense I will tell that that is stable. Means system is not going to amplify that signal, and similar kind of framework we are using. And due to that reason, for stability also we are using the same definition. So if you just see the book of nonlinear control or modern control engineering, you might have suddenly you will see this kind of definition. But most of time people become surprised that why this kind of definition basically comes into picture. First, they are not comfortable with these kind of symbols. Okay, and why basically they are not comfortable? Because they do not know what is idea of limit. They do not know meaning of limit is nothing but just a macroscope. How calculus is connected to algebra. So these kind of things give you intuition to understand the stability and everything. So now why basically we are learning some kind of control system or something. So main goal of analysis, if you have some system, so and if you know the behavior of system law, then if you give the input, then uniquely I can tell that what is the futuristic output. Similarly, using design of control, I can also control that futuristic input output, and that is the basic idea of analysis and control design. And why prediction will work? Prediction is possible because the world has regularity. Things are world changes smoothly. Smoothly means I can able to define the continuity as well as derivative. We are not beamed from point A to B, but we need to pass through a sequence of intermediate point. And later phase, we are going to see the definition of limit in form of sequences also. Okay. So I hope that up to here you are able to understand the story. So first part of a story, I have told you that suppose I have to develop some kind of machine. So how much basic hardware is required for that machine, how to understand that. So using the help such that we are able to do some kind of operations, mathematical operation. Okay, because in after doing measurement, I have to understand the pattern, and for understanding the pattern, I have to do some kind of operations. So for that, we have talked about the structure, and after that, I have connected that structure with the calculus, with the help of limit or with the help of macroscope. Now we are coming to our goal, that is system theory. Okay, how to represent some system, what kind of information I can brought from mathematics to understand the system. So up to here, if you have any confusion, then please let me know. Shekhar, could you please tell me how much time I have?
Sir, half an hour, 15 to 20 minutes are just.
Okay, okay. So up to here, if everything is clear, then now I am going to accelerate little bit of my lecture. But do not worry, means I will cover, and if something is left, then that doesn't matter. Okay. So if you understand the basic idea of the algebra and calculus, now let us come to the system, physical system. So you try to see that if you are if you are gone through first year of means school physics, at that time I have some kind of resistors like this, and I have some kind of input terminal and output terminal. Here I have switch. So based on switch, it is possible to show that if I will apply input V, and if switch on position A, then output is V/2. If I shift this switch, then whatever output voltage, that is V/4. Okay, across this particular resistor, please check it. Okay, this one can show using just a simple calculation using applying the Ohm's law. So what we have seen that based on this switch, okay, internal variable. So I have taken this switch as some kind of variable. So if you are changing the switch, then input output is going to change. So definition of a state, they are telling that the state of physical system is any property of the object which relate between input to output, such that knowledge of the input of time t greater than equal to t0, a state at t equal equal to T0 completely determine a unique output T greater than equal to T0. It means that if I know the switch at this position, uniquely I can able to tell that V by 2 is the output voltage across this particular resistor. So this internal variable is required, means I have to know the position on which position basically we have switched. Okay, so this is the state of physical system. Similar kind of things now you can extend for any abstract object. You can take any mathematical model, and we are telling that state of the abstract object is the collection of the numbers together with the input, means some internal number is required together with input such that I can get the unique number. Okay, so I have input and I have output. I have input or I have system. Now I need some primitive information. If I know the primitive information, then I can guess all quantity beyond T greater than equal to T0. It means that whatever information that is going to carry from minus infinity to that point. So a state is nothing but some kind of memory carrying variable. And if you see the control system, so I have just 3 classes of system. So one classes of system is called autonomous system. And what is meaning of autonomous system? That here right hand side, if you see, x is the internal variable, a state variable you can tell. So x dot equal to fxt. Here t is implicitly dependent, not explicitly depending on the f. So this is called autonomous. It means that system is behave itself. They do not need any extra information. Non-autonomous system means time is also involved. And force system, when controlling force is here. Now you can design control based on the state, then that is converted into autonomous system, and here then that is converted into non-autonomous system. So if you have 3 different definition, autonomous, non-autonomous system and force system, and here you can see that now whenever I am writing definition, I am using this kind of notion. This is very, very important. Why? If you do not add this kind of notion, you are not able to understand that this autonomous system is of 2nd order, 3rd order and 4th order. So how to understand the order of system? So using this number I can understand. And how basically numbers are related to geometry. So they are telling that whenever I have 0, r power 0, it means that I am at point. When r power 1, it means that I am on real line. If r power 2, then I am in 2-dimensional space. So in this way, numbers are related to the geometry. Okay, so same kind of things we are telling that we have 1-1 correspondence. So if I have to represent n-dimensional, means suppose I have some kind of physical system where current is one of a state, voltage is another state, or some other quantity is a state. So and 3 states, so r cube come into picture. After that, I have already told you that whenever I am going to talk about some kind of physical system, at that time this is f is mapping or some kind of function. So in order to represent that, I am telling that xt belongs to r, then map back to rn. And similar kind of a story here. So whenever you are going to write any papers, mathematical paper or something, please specify this kind of terminology. Then things become pretty clear. One more important thing, that here you can see that r, what is meaning of r? Because whenever I have some physical system, whatever input I am giving and whatever output I am getting, that is just a real numbers. And due to that reason, this represents some kind of real number. It means that I do not have any way to measure complex number. I have some kind of measuring instrument which is going to just measure the real numbers. That is the meaning. Okay, so now I have taken very, very simple example. You can see this mechanical system. I have used Newton's law, and after that just solve it. Okay, I have to understand that after application of this force Fx, what is the displacement? And if you calculate the displacement, try to see that 2 variables are required, xt0, vt0. I am assuming that I know the starting time of experiment and at which point I want to know this state xt. So for that, information of mass is required. I know, okay, I have a car of 100 kg. I know this. I know T0 and T. I know that how much actually fuel I am going to use, how much torque I am going to apply on car. So Ft is known to me. So now apart from this, you can see that 2 things are required, xt0 and vt0. And what is vt0? So vt0 is nothing but this term. Similarly, if you see the xt0, so xt0, vt0 is basically this particular term, and xt0 if you see, so I have defined this quantity as a xt0. So this is integral from minus infinity to t0. It means that that is going to contain infinite many information. And why that is xt0? Because velocity multiplied by time, and due to that reason I have written this as a xt0. So what in another way, whenever we have some kind of a state or internal variable, so we are telling that a state is some kind of quantity which is going to cover the information from minus infinity to t0, such that if I know these two information uniquely, I can able to identify what is my futuristic state. That is the meaning. Now I am going to define the general class of dynamical system. Okay, so I have already told you that whenever I have physical system, whatever input I am going to apply, that is real number. Whatever output that I am going to get, that is also real number. Now real number in form of the column vectors, in form of functions, in form of matrices, that doesn't matter for me. Okay, because now we are working in vector framework. So I have three different kind of entries in form of column vectors, entries in form of functions, entries in form of matrices. So we are telling that all entry somehow that is represent some kind of real number. Okay, and obviously I am assuming that there exists some kind of vector framework of a structure. Then only I can tell that using same computer I can add two matrices, two functions. Okay, and output yt doesn't depends on the input. In that framework I can define the dynamical system. And state, several times I have already told you that whenever I am talking about a state, we are telling that I have system. I know minimal number of number such that if I apply the input, such that again I will get some kind of output. Again, whenever I am talking about numbers, here numbers may be in form of column vectors, in form of functions. Why functions is a number? Because each time I am getting some kind of number. If you see function carefully, because I am talking about real valued functions only. And after that I am going to talk about the uniqueness. Uniqueness is very, very important. And for that you can see that these many axioms are required. Now why we are working with axioms? Because what we found that if I have physical system, so I know the input, I know the output, but I do not know the internal variable. So how many different way I can represent the internal variable? I have infinite many way. So how to make sure that whatever way, suppose your friend has developed some kind of new state variable and your another friend has developed some new state variable. So how to make sure that both are consistent, both are the correct. So for that some rules are required. So only 5 rules are there, and they are just talking about that real input will give us real output, whatever trajectory that is unique if you are going to give this kind of information. So these kind of properties there. So do not worry at this moment. Once you become comfortable with previous one, then you are able to understand this in very much way. One example I am going to take you. You can see that here you might be thinking that I am misleading you, because why? In electrical system you might have seen that several places I have some system, I am giving some kind of input like a e power j omega t. That is nothing but complex number. But here I am start suddenly telling you that no, I cannot give input as a real number. Okay, complex number. So what is mismatch? It is possible to show that any quantity, it might possible I have system, input output is real, but it might possible internal variable might be complex one also. Another thing I am not going to show here, any complex number can be represented using some kind of matrices where each entry is just a real number. So complex number is just telling that how to represent some complex quantity using one-dimensional framework. So one-dimensional framework in complex number is nothing but some kind of 2 cross 2 matrices. Okay, so if you understand this definition, then now you have extra freedom that you can select a state variable as a complex number also. Or if you and if you are working on quantum physics or quantum control, at that time you are able to see that people are taking a state variable as a some kind of complex number. So this is just hint to enter inside the complex quantum control, because in next generation we are going to talk about the quantum control, and due to that reason you have to understand the things very carefully. Now I have told you this kind of things. I have already told you that whenever I have real valued function, because each system, what we found that they are taking some kind of input and generating some kind of output, and this system is going to represent some kind of function only. So how to operate on that function? So I have already told you that whenever I have function, so in order to remain consistent with respect to vector space, and why we have to remain consistent with vector space, because using minimal number of hardware I want to do operation. So if you do this kind of operation, pointwise addition and scalar multiplication, then again you are able to just in hardware level, just you have to know how to add numbers, then you are able to also know how to operate on the functions. So now what happens, another thing, that after defining the vector space, what people has thought, suppose I have some system and left hand side I know that I have some system, and I know that this side I have some kind of vector space, input side. Now output side I want to make sure that there exists also a vector space. So what kind of transformation or function you can tell such that that will map from one vector space to another vector space, and it is possible to show that that is nothing but some class of system which map from one vector space to another vector space that will satisfy these two properties. Okay, and somehow this boils down to linearity principle. Same kind of things I am telling. Now I have some kind of G is nothing but linear transformation which preserve V1 plus V2 like this, that is addition, and this is a scalar multiplication kind of things. Okay, so that is called linear transformation. And why linear transformation is very, very important for us? Because in one dimension I know that what is slope at some point. Suppose you are in higher dimensional. Here I have taken higher dimensional function x square minus y square 2xy. So I cannot tell that again if you draw some kind of line to this point, so that is the derivative, because derivative is unique. Okay, so if you draw some kind of, suppose you are in two dimensional, here I am in 4-dimensional plane, 2 input x and y, after that 2 output. So suppose that if you want to draw something, then I have some kind of plane is going to hit here. Okay, but whatever derivative at some point, that is unique. So by seeing plane I cannot tell that in which direction this point is going to touch by that plane. Okay, so for that I need again mathematics, that is called linear map. So let us come here quickly, that whenever we are calculating derivative in higher dimensional space, so we are just try to find some kind of best linear map at that particular point. And how to calculate that linear map? Using some kind of Jacobian matrices. So basically you can see that again I am going to do infinite zoom here, and after zooming this I am going to select the slope in each and every direction. Okay, and that is nothing but some kind of matrices comes into picture, and that is Jacobian matrices. Okay, so linear map tells us that what is physical interpretation of derivative in higher dimensional space. Okay, so in one dimensional, physical interpretation of derivative is just a line, but in higher dimensional we are going to search those kind of best linear approximation of f, that is nothing but some kind of best linear map around that particular point that tells us the derivative in higher dimensional space, because that is required whenever you are going to do linearization, these kind of things. So what we found, that if I learn the vector space, I know how to operate, I know what is linear dependence, linear independence, and how to do coordinate change, because we have seen that fx is some function and any periodic function can be represented. Just I have given one example using cos and sine, some kind of sinusoidal. So again, how to select that coordinate frame, that message is actually transmitted by the notion of vector space or with the help of inner product. And it is possible to show that some kind of existence and uniqueness of solution. I haven't touched this. So Ax equal to B, and it is possible to show that if A is some kind of matrices, X is some kind of vector, and equal to B, that is equal only if X and column vector you can take. So if you can take each and every column vector as a basis, then if that is multiplied with X, and if that is column vector and that is linearly independent and span the space, then only I have unique solution. So this kind of framework is there. And what is major limitation in vector space? That there is no notion of distance, and for that we need one extra notion that is called non-linear space. And I hope that several times whenever you are doing some kind of analysis in classical control as well as modern control, you are using the notion of the norm, but you are not knowing that why you are using. Most of time I found I am asking a student and they are telling I don't know why I am using L infinity norm, why I am using two norm, one norm, what is connection. Okay, so norm is very simple idea. They are telling that in two-dimensional space, suppose I have 1 2 and 2 1, I cannot compare it, and due to that reason, very simple idea, you can convert or map it to one-dimensional space. And one-dimensional space, now I know that how to compare two things. So basically how to map n dimensional to one dimension, that is given by this operator that is called norm. Okay, so norm is nothing but some kind of distance in a higher dimensional space. Okay, and whenever you have distance is always positive, that is 0 whenever you are at reference point. And if you scale out distance, then obviously this is a scale out, and that will satisfy triangular property. So these three properties is satisfied by distance, and norm is nothing but the generalization of distance. And now you all of you are knowing that I can measure distance by millimeter, kilometer, centimeter, decimeter, and all are equivalent in finite dimensional space. Okay, so whenever you are going to buy the cloth, you are going to measure the distance in meter. Whenever you are going to make the road, you are going to measure the distance in kilometer. Whenever you are going to do plot some kind of graph, you are going to use some kind of centimeter. But all are connected. But we know that when I am going to use it, I know the application. Due to that reason, first you have to understand the notion, different notions, similar kind of things. Since there are infinite many or at least very large number of notion of distance, similarly I have different way to define the norm in same space. So I have a space Rn. Rn means I have some kind of vector where column vector where entry is x1, x2, x3 or xn. You can see here. So whenever I am going to define now the norm, this is called infinity norm. So infinity symbol is used here just in order to characterize that x is vector space. Vector space means I am going to add two vectors and that is going to remain in same space. They will satisfy all axioms and a scalar multiplication. So that kind of things I am going. So I know how to operate on it. And after that, now I am going to translate n dimensional space to one dimension. You can see here that right hand side only I have absolute value. So what basically they are doing, if you know how to calculate absolute value, I can able to calculate the norm. In second notion, just forget about this. In right hand side, you can see that again absolute value is there. Here also again absolute value in P norm absolute value is here. So hardware level, if I know that how to calculate the absolute value, now I have some kind of hardware which can compare two kind of quantity. Then I can able to develop lot of norm. Okay, so here somehow whenever I have vector, then only one hardware is required, and after that software programming will do all kind of job. So this is the definition, and all three properties are satisfied this. And here this is called x1 norm. You can just take summation and you can see that this is always positive, same like distance, and this is generalized norm, this is P norm. So based on our requirement, we are going to use this kind of norm. So sometime we are going using infinity norm, sometime we are using one norm or something like that. Okay, so you can see carefully that if you take two norm, then here everything is x1 square 1 power 2 is there. Okay, so whenever I have differentiability requirement, at that time I am not going to use this kind of norm. We will see that during stability, Lyapunov stability, we are going to do this. Now, if you are able to understand that how to measure the distance in higher dimensional space. Now, if you have two quantity, then you can tell that two quantity how much close they are. The two quantity are. What you can do? You can just put that two quantity inside that notion of distance, and x and y, if they are x minus y, so we are going to think that distance between x and y, and if both are very close to each other, they are going to converge at some point, and then we will give the definition of limit. So what basically we are telling, I am in function space, so I have some kind of sequence, and if that sequence is going to converge to some limit, then this relation will satisfy. Okay, Now this is the definition of ball. So now you can see that whenever we are talking about ball, we think that ball is always some kind of quantity that is remains spherical or some kind of things. But here notion of ball is very, very generalized. So that might be a line, might be a point, might be in a sphere or any other structure. But generalized definition of ball is like this. So basically sequence is telling that finally after some kind of number, and you are going all value of sequence is going to fall inside that ball. That is the another physical interpretation. Okay, now another thing, since whenever I have physical system, I am mapping from that particular system is going to map from input space to output space. And I have told you that continuity also gives the idea of bondedness. And basically continuity is based on the idea of bondedness only. And that is connected to the limit. So same kind of definition is applicable. So I know that how to measure the distance in higher dimensional space using now you can see that same kind of definition I have used here. Whatever definition I have used for limit in the one dimensional case, we are telling that for every epsilon there exists a delta such that if output is bounded by this ball, then input is going to remain inside this ball. And this is continuity at point x0. If same kind of relation is satisfied everywhere, then we are telling that function is continuous at all x belongs to x. And uniformly continuous means this delta is no longer function of x0. So that is called uniformly continuous. So these are the definition, but main crux of the matter is like this. If you understood the definition of limit, now what we have to do, we have to zoom out the output. Okay, and we have to make sure that whatever zooming relation epsilon, if that is depending on the delta, whatever zooming relation on the output side epsilon and whatever zooming relation in input side delta is depending on the epsilon. If you are able to find this kind of relation, then you are able to give guarantee that if you apply bounded input, then you will get the bounded output. And these are the epsilon delta definition of the stability. What we are telling that x dot equal to fx. So this is differential equation, and it is possible to show that solution of differential equation is nothing but some kind of function again. So I have function like xt I have represented. So if I will give some kind of input x0 initial condition to this system, because this is autonomous system, then output xt is generated. Now what I am going to do, I am going to select output ball. Why output ball we are selecting? Suppose that whenever I am going to develop some kind of machine, what basically we are doing? First we are doing survey. We are asking the requirement of users. So once I know the requirement of user, then I am going to develop some kind of machine, and I am telling if you give this kind of input, then your requirement is fulfilled. Similar kind of definition here for every epsilon, and epsilon is connected to the output ball. Xt minus 0 is ball, and ball I have already defined. Then we are telling that there exists a input ball delta that is function of epsilon greater than 0 such that this relation will satisfy. If something is not satisfying this, then system is unstable. Okay, means we cannot able to formulate for every epsilon. I am not going to formulate one delta ball, at least one delta ball, and this is called bondedness. And apart from bondedness, what happens that sometime I have to give guarantee that once we are acting at the equilibrium point. What is property of equilibrium point? If you start from equilibrium point, you are going to remain there. But if you are going to deviate from equilibrium point, most of time what we wish that I can again come back to the equilibrium point. But stability doesn't tell us. They are telling that if you are deviated from the equilibrium point, x equal to 0 is the equilibrium point, and you can see the definition of equilibrium point like this. If you couple here x dot equal to 0, x represents some kind of quantity like position vector, and x dot is velocity vector. Now just what you can do, you can keep velocity vector equal to 0 and apply Newton's first law. Then it is possible to show that since velocity is 0, then I cannot move. So that is the interpretation of equilibrium point. And once you are deviated from equilibrium point, so stability is telling that your future state or future trajectory is not going to deviate much. And how to come back, that is given by asymptotic stability. So they are telling that I am not going to deviate much, but as t tending towards infinity means very large time, then I can again come back to the equilibrium point. So that is meaning of asymptotic stability, means they are going to talk about the bondedness plus convergence. Okay, so these are the broader picture. So here you can see that I have system, and I know that in which space I have to maintain. Here I have just taken first order system. Due to that reason, I replace the absolute value, norm by absolute value. In one dimensional space, there is no difference between notion of the absolute value or the notion of norm. So here fxt minus fx0, and we are telling corresponding to this there exists a ball, a space of all input. So Lyapunov stability just examine that if I remains very near of the equilibrium point, system might be linear and non-linear, then what is the future step? So now you can take any black box system and using the notion of continuity, you are able to explain it. That system is stable or not. If also converge to the equilibrium point, then we are also able to talk about the asymptotic stability. And same kind of things here I'm telling that now you can take any first order system. So using Newton's law, you are able to visualize it. So suppose this is first order system, then you can draw a line. And now what you can see that if you are here at this equilibrium point, so V is 0, then V dot equal to 0. So by Newton's first law, I can tell that if something is represented by first order vector differential equation or first order equation, then just if I keep rate of change equal to 0, then I can able to define the equilibrium point. After that, now you can see that if you are not at 0, then if you start from here, then what happens? V is positive, but V dot rate of change, if you see couple here, V is positive and Kp suppose that is greater than 0, then V dot is negative. So V is positive, V dot is negative, rate of change is negative. So by Newton's law, again you can move towards the equilibrium point. Okay, so this notion is somehow telling us that if you start anywhere and if you have this kind of relationship, I can move towards the equilibrium point. And again, this is autonomous system. Okay, so same way epsilon delta, I can select that if I will select or any output ball, so corresponding to that I will tell that I am going to remain nearby of the equilibrium point. Okay, so similar and here if that is case of asymptotic stability. Now this is case of stability. So suppose that if you have some kind of disturbance or perturbation at some time, what happens? V is positive and V dot that become positive. So if your gain is very high, so in this side what happens? V is positive, V dot is negative. Due to that reason, you will converge like this. Similar kind of situation here. But inside this, what happens? V is positive, V dot is also positive. V is negative, V dot is also negative. So you are diverging. But what happens that you have some kind of boundary where what happens in this side of boundary, V is positive and V dot is negative. So we no longer diverge. And this kind of situation is represented the stability. And asymptotic stability, just what we found that here I do not have any perturbation. So what happens that always I can maintain V is positive and V dot is negative. So I slowly move towards the equilibrium. Why slowly? Because as V is decreasing, your rate of change is also decreasing. And due to that reason, infinite time is required to move from here to this point. So this is another intuition of stability from the Newton's law. Okay. So Shekhar.
Yes, sir. Yes, sir.
Do I have time?
Sir, you can still take 5 minutes and
Okay.
5 minutes per question and answer.
Okay.
I think we'll have next session actually.
Okay. Okay. So now what I am going to do, I am going to skip. So what is another idea? That is called Lyapunov stability, and it is possible to show again that is based on same intuition. So I am going to skip this part, and now one more important thing where calculus is applicable, that is optimal control theory. In optimal control theory, what is our main objective? Main objective is to determine control signal that will cause a process to satisfy some kind of physical constraint, and it is possible to show again. You can see here that I'm going to minimize some kind of function. So in calculus, what basically we are doing, we are trying to find some kind of optimal point of the functions. In optimal control, we are mapping from Rn to R plus, and there that is called functional, and again same kind of relationship is satisfied. Okay, so in this way, optimal control is also connected with the function. Another more another important point I forget to tell you, this slide. Here you can see that suppose I have some kind of process. Now you might have, all of you are already well aware about the PID controller. So basically, again, idea of PID controller is fully based on the calculus. What they are telling, that suppose I have some kind of process and I have input, output, and I have some kind of set point. So I have to maintain the set point. How to maintain that set point? Whenever error comes into picture, then based on error I have to take the decision. Okay, so you have three things if you are here: present, past, and future. Okay, so I can make decision based on present, or most of time what we are doing, whenever some new situation come into picture to us, we are making a decision in three different way. We are seeing the present, past, and future. Okay, so we are thinking, okay, in past time these kind of event come into picture. If that is not, then we are also looking towards the futuristic. What is future? In future, what kind of things is going to happen? Now, similarly, control theory is telling that in order to represent present, you have proportional operator. This operator, integral operator, is going to represent the past. I have already told you the idea of the integration that is given by Newton. They are telling that how to calculate area under this curve. You can zoom out it and after that calculate the area. So this operator is telling that how to represent the past information, and derivative, that is slope at this point, that is futuristic information. So since I am taking decision based on past, present, and future, so calculus is telling that I have operator which is going to translate your thinking in form of mathematics, and that is nothing but proportional, integral, and derivative operator. And here now I have to select this gain Kp, Ki, and Kd such that I am able to minimize that error. So if you are going to minimize that error optimally, I have already told you that what is meaning of optimal control. Again, you have to go through it because I don't have time to do this. It means that whenever we are designing control, that is based on that five information only: information of present, past, and future, time, and gains. Okay, so if you have five information, then I can able to control the process, and all control system actually fall inside this only. So PID controller is a still, if you tune it beautifully, then it is possible to show that their response is better than all other kind of controller, because you have everything in your hand, so you can tune it. Okay, so that kind of message I am going to transmit from the calculus side. So with this remark, and one more important thing, that several lectures, at least 150 lectures I have recorded in this COVID period, and that is available on this channel. So because time is very short, so I cannot talk everything. So system dynamics and its related problem has been discussed using fundamental of mathematics, and this is the statement that is given by Ramanujan, that whenever we have mathematical equation, they represent some kind of physical understanding. Okay, so an equation means nothing to me unless it expresses a thought of God. So if you see equations, some kind of algebraic equation, differential equation, or any class of equation carefully, you are able to relate it with some kind of physical phenomena. That kind of message I have. So with this remark, now session is over from my side. So if you have any question, then please let me know.
Thank you very much, sir, for your this journey from mathematics to control. A lot of mathematics, everybody knows they involve in control, and you have enlightened some spark to those things. So I'm sure that I have also been benefited. All the participants must have been benefited through this fruitful lecture. So participant, please, if you have any queries or questions, you can unmute yourself and ask directly, or either you can write in the chat box, or even in the WhatsApp, you just write it. I can ask on behalf of you. Anybody, if you have any question, please.
Sir, I have a couple of questions, sir.
Okay,
Yeah.
please go ahead.
Okay, sir. First, I thank you for highly informative session, sir. And okay, I'm also following your YouTube channel, sir, regarding number of lectures you uploaded on during COVID time, sir. So based on this, I have two questions. So how to validate the model of any physical systems? once I have a model with me based on the first principle of the system, and
Okay.
second thing is whether linear controller or non-linear controller is best choice for in physical systems.
So, so now first thing, how to validate the mathematical model. So based on my understanding, whenever you have system, then in three different possible way, it is possible to model some system. One is that you can use the fundamental law. So suppose that if you are working with electrical system, then you know that KVL, KCL, Ohm's law, these kind of things you are knowing. And based on that theory, you are going to develop some kind of mathematical model. Okay. Another framework is also called data-driven framework. So they are telling that I do not know, system is very, very complex nowadays. So suppose I have power system or some kind of cyber physical system. So now if I have some kind of input and I have output. Okay. So based on input and output, if you do not know the physical law, okay, then how to develop some kind of mathematical model. So that is called data-driven framework. Again, that is heavily based on the linear algebra, and idea is very, very simple. At macroscopic level, everything is a straight line. So you are going to apply same kind of theory. Okay. Now, third thing is that is based on energy. If you have information of energy or energy like quantity, then you can use the Lagrangian framework to develop the mathematical equations. So once you have mathematical equation, now suppose you have some kind of physical system. So same input signal you can give to the system and this to that mathematical model. So in simulation platform you have model, and physically you have model, and you have some kind of input and output, some kind of you need some kind of sensors to measure input and output. Similar, and input and output, you have some kind of a scope inside the simulation platform. So and now you can compare that means output, whatever you are getting from the physical system or whatever you are getting from the mathematical model. And how to compare, again, it might be possible I have more than one number of output, then you have to define some kind of norm. So either you can take, because in finite dimensional space all norm are equivalent, so either you can take L2 norm or L infinity norm, then you can compare. If you are able to find that this norm value of norm is very, very small, then you are able to tell that, okay, I do not know what is law of this physical system, but if I will represent this system by this mathematical equation, then this particular mathematical equation will work, and due to that reason, this is the reasonable model of this particular system. So this is for validation of model. But if you are working with control, so for control purpose, complicated models are not required. You can take any simple controller, a simple model. Okay, you can neglect lot of quantity. At that time, now you can see that I have two different things. If your model is very, very perfect, okay, and you are operating about some point or about some trajectory, then linear control will work. Okay, suppose your model is not so carefully, you haven't done modeling. At that time, you always need some kind of robust control, and almost all robust control contains some part from the nonlinear control theory. Okay. So in that, if you want to use very, very simple model, then at that time nonlinear modeling principle is very, very important, because we are neglecting lot of things. But if my model, so two things, my model is very, very perfect, and how to tell that something is perfect, you have to do those kind of experiment, and you have to make sure I'm not deviating much about the operating point. Okay, then you can use linear control theory. Another recent thing I have seen that what happens, that polytopic modeling. What you can do, even if you have nonlinear system, but you can do the polytopic modeling about several operating point, and after that you can if some assumption is satisfied, it is possible to show that linear model will work there. So you can also work on that particular framework.
Okay. Thank you, sir. Thank you.
Welcome.
Okay, and one more thing, sir. If you allow me, can I contact you in future?
Yeah, obviously. Anytime. You can see that every lecture links are given, or most of time I am not giving phone numbers, but everywhere that email ID is given. Okay, so it is better that you can drop me email. Most of time I am replying within one day. or 1 hour, 2 hours, something like that.
Okay,
So
thank you.
please
Thank you very
hesitate
much.
and contact.
Thank you very much.
Welcome.
So any other question from the any other participant?
Hello, sir.
Good
Ah,
morning.
please.
Sir,
Good morning.
if industrial application means if I want to control any level flow for the boiler means how to derive the mathematical model, sir.
So actually what happens that some kind of application people are thinking that mathematics are useful, but that is not the case, because suppose that if I have to control some kind of flow, whatever tank system, two tank system, or some other tank system. So one of the good framework is that data driven. Okay, so what you can do, you start doing experiment, you can take some random signal, and after that you can collect the data. And it is possible to show that using singular value decomposition, that is again the subject of the linear algebra. So and again you are able to understand what is vector space, what is basis. Then you are easily able to understand that what is singular value decomposition. Then you are come up with some limited amount of data. You are able to truncate the data, and after that you have to find the pattern inside that. So how to find pattern? You can take any discrete model, xk plus 1 equal to 5k into xk. You can now you can train your model. Okay, and then you are able to come up with some kind of law, and again you are able to apply or design some kind of control theory for that purpose. So for learning model, again use of linear algebra is very pretty much required. Okay, so every process, whatever you can do, you have to go via the linear algebra, okay, or abstract algebra. But what people are thinking that they are SVD, they are singular value decomposition. Suppose people are doing, they do not know why things work. They just know how things work. But I think that it is better if you know why things work. Then you can improve. You are able to select data in more efficient way, and then you are able to guess what kind of model is applicable for my purpose. So one very good book that is available, and their lecture series is also available online. That is Data Driven Modeling and Control. Please go through that book. That is nicely written, very nicely written. Programs are given, lectures are given, and books are also given.
Sir,
I think
repeat the book name, sir.
Data Driven Modeling and Control. Or you can just drop me. I will send that book to Avdesh or Shekhar, and Professor Avdesh and Shekhar will send that book to you. Is it okay?
Oh, yes.
Yes, definitely, sir. Will share with the participants.
Very nicely written. All programs, everything is given there.
Okay, sir. Thank you, sir.
So that book written by Steve Brenton?
I forget the name of author. But they have worked a lot on data-driven framework.
Yes.
Any other questions? And for linear algebra, I think that lecture of Gilbert Strang, he's one of the favorite professor for me. So that is means you can means you have to hear the lecture. He's 80 years old professor, but very energetic, and all lecture every time he's connected with some kind of he connect mathematics with reality or some kind of system. You are easily able to visualize his lecture. Gilbert Strang. Any other questions? You can also tell the suggestions.
Hello,
so
sir.
Suggestions is also means welcome, because I am also learning that how to teach a student. Because most of time what happens that slowly we are knowing what is real analysis, functional analysis, everything we learn. Due to that reason, what happens, most of things become obvious to me, but that is not obvious to the audience. So if you have any particular suggestion, then please let me know.
Hello, sir.
Please go ahead.
Sir, two questions. First, I have to ask, suppose that if we have a nonlinear system, so for stability, am I audible, sir?
Yeah. Please go ahead.
For stability point of view, we use two methods. first begin.
So what I think that means two books are very, very important. So actually book of Khalil, okay, nonlinear systems. Now a nonlinear control book is also written by Khalil, but that is reduced version of nonlinear system. So if you have some idea of mathematics, then please go through that book, nonlinear system book. And if you are not so much comfortable with mathematics, then book of Professor Slotin. Again, applied nonlinear control. Perhaps that is the name of book. So please go through that. Okay. But whenever you want to write some papers or something like that, at that time, book of nonlinear systems that is written by Khalil is recommended. And believe on me, that is very, very nice book that is written by. Okay. And if you have any difficulty in order to understand the stability, why stability definition is written in the plain delta form, and most of the time what happens that people are not knowing the logic, mathematical logic, that is grammar of mathematics. So actually I have recorded lecture, 25 lectures till now I have recorded, and I hope that I will record 15 more. So I will cover all three kind of stability. That stability about the equilibrium point, and after that stability input and output stability, or input to state stability, you can tell that that is based on K or KL class function, and stability about the periodic orbit. Okay, so these are three framework of the stability. I hope that I am able to cover inside that online lecture. Okay, so parallelly, what you can do, you will go through Khalil's book, and after that, at the same time, you try to hear the lecture. Then I think that that you are comfortably. And one more thing, some exercises are given in the Khalil book. So I'm not telling that you have to means you are able to solve all exercise, but what happens? Solution manual is also given. Okay, so please go through solution manual. So once after solving that problem, you try to check that whatever way you have solved, that is consistent or not. Any other question? Do you have any other question?
No, sir.
So even if the participant had other questions, so they can email us or even directly to sir, and it will be replied. And now, sir, we are actually heading towards our session 4.
Okay.
So
Sorry, I have
no problem at all. No problem at all, sir. We already covered a lot of things, and thank you once again for delivering such a nice lecture and making this RACES 2021 as for your contribution. It's just for the success.
Thank you very much for invitation. Okay.
Okay.
Thank you, sir.
Thanks a lot. Hello. So you all are nicely conduct lot of workshop. I hope that now become little bit familiar with control and these kind of things. Obviously, we are lacking in terms of implementation. So some more lectures in future we will implement where we will take some setup and from the primitive from the basic point onward we are going to build that system, and we will show them that how to build some kind of new systems, how to do analysis. All 6 different problem I have categorized that if you are able to solve 6 different problems, then automatically you are able to handle any industrial problem. So in that prospect, one student is making lectures, and they are also implementing on some kind of means robotic setup. So if that is possible, then I hope that means people become little more comfortable, because most of time if you are using mathematics, then people are thinking, oh, something mathematical things are going on, and that is not useful for me. So I hope that in future.
Thank you, sir. Thank you very much.
Okay. Thank you.
So, dear participants, already